Hello there, good math people. Today we're going to take a look at a different pond project than we had in Topic 3, Block 5. This is Topic 3, Block 6. As you can see from the picture, there aren't tiles surrounding the pond, but a fence. Because according to the scenario here, customers often prefer to have a fence surrounding the pond rather than tiles. So we're going to investigate the relationship between the side length of the pond and the number of feet of fencing that is required to surround the pond. Now what we're going to do is we're going to create we're going to create a table, a graph, and an algebraic rule to represent this relationship between the side length of the pond and the number of feet of fencing that it would take to surround the pond. As you can see, the fencing is right on the edge of the pond. We're going to use S to represent the side length and F to represent the amount of fencing that is needed. So when we're all done, we're going to compare our representations to what we've got. So let's get started. Okay, well now here we find ourselves on Topic 3, Block 6 in your math book. So you want to make sure that you find Topic 3, Block 6 in your math book before you continue on. So pause the video, get your math book, and let's get started. When you're done copying the graph that I've drawn here, you'll want to continue the video. Okay, so let's get started. We're going to create a table, a graph, and an algebraic rule to represent the relationship of pond side length, or S, to the amount of fencing. So let's say, zoom in here, let's say that we have a pond that has a side length of 1. How much fencing would we need? Well, we're going to need a foot of fencing on each side because it's 1 foot per side of the pond. Now that's a mighty small pond, but so we would need 1 foot of fencing times 4 sides, and that's going to equal 4 total feet of fencing. If the pond had a side length of 2 feet per side, it's a square pond, every side is 2 feet, well then we'd have to have 2 feet multiplied by 4 sides of the pond. 2 times 4 is 8. Okay. Now let's take this up to, how about 4 feet? Well, let's see. If the side of the pond is 4 feet, then we would need 4 feet multiplied by 4 sides, and 4 times 4 is 16, so we would need 16 feet of fencing. And if we wanted to use, let's say, 10 feet of fencing, not 10 feet of fencing, 10 feet on the side of the pond, 10 feet per side of the pond. That's 10 feet multiplied by 4 sides of the pond, and 10 times 4 is 40. Okay, well, we can graph this if we want to, which of course we do. 1 foot on the side of the pond would need us to have 4 feet of fencing. So you can see how the graph is laid out here. Here would be 1 foot on the side would require 4 feet of fencing. It would be out there. 2 feet of fencing would require, 2 feet on the side of the pond would require 8 feet of fencing. 4 feet side length of the pond times 4 gives us 16, so we would need 16 feet of fencing. That's about 16 there. I have to estimate in my graph. And if I jumped all the way up to 10 feet on the side length of the pond, 10 feet, I would need 10 times 40, 10 times 4, which would be 40. Okay. Now, we look here, we can see that if we were to connect all of these dots in our graph, it is a straight line, so it is linear And we can see that the line runs all the way down through the origin right there at 0, 0. So it's a straight line through the origin. And what does that tell us about the relationship then between the amount of fencing and the side length of the pond? That relationship is proportional. It is a proportional relationship between the side length of the pond and the number of feet that we need of fencing to surround it. But what we want to do next is to come up with the algebraic rule now, so that we can, no matter how many feet we want the pond's sides to be, we'll know how much fencing we will need. So I'm going to replace the numbers on the side length in our input. I'm going to replace that with our variable s for side length. And so then if we do that, then it would be s times 4 would equal f, the amount of feet of fencing. Now so if we wanted to write our algebraic rule, we're going to turn all these things around. The amount of fencing that we need, or f, will always be equal to s times 4. And what is s times 4? You guessed it, s times 4 is 4s. 4s. 4 multiplied by the number of feet on the side will tell us exactly how many feet of fencing we will need. That's fantastic, right? Of course it is. Okay, well, let's move on to the next section here. Now that we know the algebraic rule, we know it's proportional. We've drawn our graph. We've completed the table. It's amazing. And now any place on here, I could say, hey, what does this point right here mean? What is this spot right here on the graph? And you would be able to tell me, hey, that means that if you have a pond that has a side length of 8 feet, the number of feet of fencing you would need would be 32. Because if you go from 8 up to our line and then follow it back over here, then you know that's 32. Pretty amazing. Plus, if we did that same thing with our algebraic rule, 4 multiplied by 8 is 32. Awesome. Just awesome. All right, let's see what we need to do next here. Scrolling to the next page. Now, if you found a proportional relationship in question 2, identify the constant of proportionality using each of the representations and explain how you found it. Well, gosh, it seems awfully easy, right? Remember everything we've learned so far about the constant of proportionality? Constant of proportionality, you can always find the constant of proportionality or unit rate by dividing the output by the input. And the output in this case is the amount of fencing, or F, and the input is the side length of the pond, or S. F divided by S will give you the constant of proportionality. And you know I like to use M for my constant of proportionality. Okay, and in each one of these cases, let's see, 4 divided by 1 is 4. 8 divided by 2, 4. 12 divided by 3, yep, 4. 16 divided by 4, 4. And there you have it. We found the constant of proportionality from our table. The constant of proportionality in general, remember, is always the output divided by the input. That will always give you your constant of proportionality or unit rate. And in this case, it's the amount of fencing for one side of the pond. Now, from our graph, how did we find our constant of proportionality? Well, remember, we can always find the constant of proportionality from a graph by dividing the input by the output. or in this case it was f divided by s. That will always give you your constant of proportionality. The other thing, remember, we have x, y pairs, or input-output pairs. And remember, on a graph, if you can find when x is equal to 1, the constant of proportionality is always the y variable that goes with that. So when x is 1, y is the constant of proportionality. Again, when x equals 1 on your graph, y is the constant of proportionality. And when we look at our algebraic rule for a proportional relationship, remember our algebraic rule was the amount of fencing needed is equal to, in this case, 4 times s. And we have learned again and again and again that the constant of proportionality is always the coefficient of the input. And we've been using y equals mx, and that's the coefficient of the input. All right. Moving on to the next page. We should be able to complete this statement to show what we've learned about the proportional relationships. Here's what I want you to do. No cheating. I want you to fill this in. Fill in the table as best you can using the word bank. Well, I didn't want to do that. Use the word bank. The words from the word bank. You might use all of them. You might use some of them twice. There's a word on there you might not use at all. Who knows? Do the best you can to fill it in. Read it critically. Pause the video and fill it in. And then when you're done, check your answer. No peeking. Okay, now's your chance to check your answer. The graph of proportional relationship is a line that passes through the origin. The constant of proportionality is the rate of change. Remember, we also call that the unit rate. You can find the constant of proportionality, I abbreviated because it wouldn't fit in the box, by comparing the ratios between the pairs of values in the graph or in the table. Remember, that's always the y divided by x will help you find the constant proportionality. In the graph of a proportional relationship, the y value of the point 1, remember when x is 1, the y value is always the rate of change or unit rate and the constant of proportionality. Okay, well, I hope you did well on that. If you didn't get these answers, make sure you go back and erase and rewrite them. Thanks for not peeking. And let's go on to the next question. All right, let's consider this image that's created with 4 different circles. And we're going to take this a little bit differently than what the book wants us to, and that's okay. Now, write an expression that describes the total number of intersections in the image. Well, let's find the intersections. This is where the lines cross over each other. There's an intersection there, and there, and there, and there, and there, and there. So, rather than, now we know how many intersections there are. There are 1, 2, 3, 4, 5, 6. 6 intersections. And how many circles are there? There's 1, 2, 3, 4 circles. So 4 circles is going to give you 6 intersections. Okay. Now, let's, for fun here, let's create a table, because I think that would be handy. We're going to create a table, and we're going to have an x and we're going to have a y. X, and y, input and output, and we're going to compare the number of circles to the number of intersections, because that's going to help us in the next question. So let's see here. When there was just one circle, how many intersections were there? Well, if there's just one circle, how many intersections are there? Well, there's none. But when you add a second circle, there are two intersections. So for two circles, you would have two intersections. How many for three? Do you think it'll be three? I hope not. Add another circle to that. So three circles, how many intersections? Well, now we have a total of 4 intersections. And when we add a fourth circle, we have a total of 1, 2, 3, 4, 5, 6. So 4 circles, 6 intersections. And 5 circles? 5 circles. We have 1, 2, 3, 4, 5, 6, 7, 8 intersections. Alrighty. Well, let's take a look here. When we go from 1 to 2 on our x side, how much does it increase over here? Well, from 0 to 2, it's plus 2. From 2 to 4, that's plus 2. From 4 to 6 is plus 2. And from 6 to 8, that's plus 2. And if we wanted to find out, what about if we have 0? I don't know if we're ready for this. Let's take a look first of all at the process. Let's look at the process to get from one side to the other, to get from the number of circles to the number of intersections. I'm going to start with the 2. How do I get from 2 to 2? Remember, I have to use the input number every time. How do I get from 2 to 2? Well, I could multiply by 1. 2 times 1 is 2. That's good. But is 3 times 1 4? No. So that doesn't work. The other way I can get from 2 to 2 is to add 0. 2 plus 0 is 2. Is 3 plus 0 4? Nope. So that won't work. So that means I have a multi-step process. If you want to pause the video and see if you can figure out how to get from 2 to 2, I recommend you do that now. Pause the video and see if you can figure out the process to get from your input side to your output side of your graph. Okay, well, welcome back. I think I found the process. In case you didn't, I noticed that, well, if I multiply 2 times 1, it doesn't work. I mean, I can get to 2, but I can't multiply the other because 2 times 1 gives me exactly 2. I can't add anything to that, and so that puts me at a disadvantage. I can't do it. But what if I multiply 2 times 2? Now that's 4. How do I get from 4 to 2? Well, I'd have to subtract 2. So 2 times 2 is 4, minus 2 is 2. Will that work for the next one? 3 times 2 is 6, minus 2 is 4. I think I found it. 4 times 2 is 8, minus 2 is 6. So you can see sometimes you have to subtract a number. 5 times 2 is 10, minus 2 is 8. And that's okay. It's okay that we can subtract to come up with our pattern. And so now, if I put x here, that would be x times 2 minus 2, and that'll give me my y value. And so my algebraic rule would be y equals x times 2, which you know is 2x, minus 2. Now, the other day we talked about what would happen if I got rid of the stuff in the top column and I replaced it, and I said, okay, what about when x is 0? When x is 0, now first of all, let's I guess I forgot. Let's use 1. 1 times 2 is 2. Minus 2 is 0. So that works. What about when we use 0? What's 0 times 2? Well, that's 0. And minus 2, 0 minus 2, though, that's negative 2. And we talked in class the other day about how, look at this, we are increasing by 2 every time. And where does that 2 show up in our graph or in our algebraic rule? It shows up right here as our coefficient of x. And then this piece right here, this minus 2 right there, where does that show up? That shows up as the number that's being tacked on to our algebraic rule. And we have discovered that, remember, when you have an algebraic rule like this, that says this is a non-proportional relationship between the number of circles and the number of intersections. How do we know it's non-proportional? Well, something's being tacked on at the end. You can't simply multiply. And remember, the other thing about that is when we divide our y by our x, do we get the same answer every time? I'm going to erase all of this. And I'm going to do that division. 2 divided by 2 in this row is 1. 4 divided by 3, definitely not 1. It is 1 1/3. So right there it tells you non-proportional because I don't get the same answer every time. There is no constant of proportionality, so we know that is non-proportional. All right, good stuff, good stuff. We've already done this. We're not going to worry about it, except we would know if there were 7 circles. Well, now we know if there are 7 circles, you know what? I'm going to reverse that. Let's find the number of intersections for 7 circles. Well, we can use our algebraic rule. The number of intersections is equal to 2 times our input, which is the number of circles, so 7, minus 2. 2 times 7 is 14, minus 2. 14 minus 2 is 12. So if we had 12 intersections, not circles. If we had 7 circles, then we would have 12 intersections. And thanks to the algebraic rule, we can find that out for any combination of circles. And we've already done this. Now this says write a general expression for a pattern with n circles. Well, you know, we know that the number of intersections will be equal to 2 times n minus 2. Okay, that's it. The rest is up to you to figure out. Good luck with the rest. Have a great day. Don't forget to be awesome. See you next time.